My name is Aaron Pletz, and today I'm going to take you through building a linked list in Java. Linked lists are important data structures to understand. We'll get into a little bit about what makes a linked list, unique in and of itself. But it's a good data structure to understand. There are a lot of use cases for it, and you may be asked to do it in an interview someday. You never know. So let's go take a look at a linked list. First of all, we can briefly cover what a linked list looks like conceptually speaking. Essentially, it's a list where the order is maintained from one item to the next. Now you'll notice it's not sorted in any particular direction, but in this case, essentially we're looking at a list of mythical cities, where you have like one city named Eldom. And the way that we know that Christwind is the second city in the list is that Eldom knows that that is the next item. And then when we look at Christwind, if we wanted to go forward, we know that Fallrayan is the next item. Or rather at Christwind, if we wanted to go backward, we notice that Eldom is the previous item. This actually brings up a good use case for a linked list, and that would be, directions. You'll have steps and directions that are linked one to the next. You can't know that you should turn left at 93rd Avenue if you're not at an intersection where 93rd Avenue is. So it kind of works out that way. Anyway, let's go ahead and take a look at the code. So the first thing I'm going to do is create a new class here. I'm just going to call this class item. And that's it. We'll just create an empty class, just like that. Now, this item is only going to have a couple of properties. So first of all, we're going to make sure that this item has a name, private string name. And then it's also going to have to know what the next item is and what the previous item is. So we can say private, and we can reference itself, previous, if I can spell, and private item next item. Just like that. And then really quickly, we can also provide some getters and setters for this class. So we can say public string get name, and you can say return name. We can even use this dot name. How about that? And you can say public item get previous item. I want to make sure that that item class is capitalized. And likewise, you can say public item get next item. And we'll want to return this dot next item. All right. Now, we'll also want a constructor here. Just, we'll say public item, and we'll say string name, item previous, item next. And then we can set all of these options as well. So we can say this dot name equals name, this dot previous item equals previous, and this dot next item equals next. Just like that. And it also couldn't hurt to have some setters here. So let's go public void set name, and we'll say string name. And then we can say this dot name equals name. And then we can also say public void set previous item. just like that. And then we'll also want to have a setter for the next item as well. So I can say public void set next item, item next, and then say this dot next item equals next. There. That should do it for the item class. Next, we're going to move on to kind of our main class here. So let's say new class, and we'll just call this LinkedListMain. We are going to want to have a public static void main method. So we'll say finish, and we can get rid of that to do. All right. We're also going to want to make sure, before we get too far there, that we have a linked list class. So we're going to say linked list, just like that. So we'll just kind of create that. And, you know, it's going to have a few private variables here. So we'll say private item. We'll keep track of the first item. Private item, last item, the last one as well. And we'll keep an active count of how many are in the list. And we'll initialize that as 0. All right. So let's start out with two constructors here. We'll just go with a simple no item or no argument constructor. We'll leave that blank for now. We'll also say public linked list, and we'll pass along an item as well. And what we'll do this time is we'll call the add item function or method that we haven't written yet. So let's go ahead and write that quick. That's going to be something we'll want to be accessible outside the class. So we'll denote that with a public scope, public, and that's going to be a void add item, and we're going to say item new item, just like that. And then we'll say if list count is 0. We're going to say set with 1 item and then pass new item. Now, of course, we haven't written this yet either, but we'll get to that. So then we'll say in the else, we'll say the new items next is the current first. So we'll say new item dot set next item, because we're adding items at the beginning of the list, and we're going to call that we're going to say first item here. So whatever is the first item, we're going to set as the next item on the new item, because the new item is the new first. All right, then we're going to set the original first previous to new. So now we can say first item dot set previous, is also going to be new. And then we have to set new item as the new first inside of our linked list class, of course. So here we can say first item equals new item, just like that. And of course, when we're adding, we're going to want to increment the count. So we can say list count. I cannot type today. And I'll say plus plus, just like that. Okay. Now, obviously, we need to take care of this set with 1 item method. So that one's going to be pretty easy. We can just say private void set with 1 item. And I'll say item, new item. Hey, see, there we go. And now that disappears. Well, at least we have it stubbed out properly. So now we can say first item is the new item. And since we're creating this list with only one item in it, both the first and the last item are going to equal the new item. Simple enough, just like that. All right. Now this add item here, we should add a comment in here. Adds to the front of the list. All right. So what if we wanted to add an item at the back? Well, we should have a method for that as well. So we can say public void add item at back. And we'll say item, new item. And same thing here. We say if, list, check for the list count. If it's 0, well, then this becomes really easy. We just say set with one item, just like we did before. Because when there isn't a list, there's no front or back either, so it really doesn't matter. So now we can say our new items previous is the current last, because we're adding the item at the back here. So the new item becomes the new last item, making the current last item the new item's previous. So we can say new item dot set previous new item, just like that. Now we can say set the original last the original's last next to new. So now we can say last item. Oh, my bad. We almost had a bug there. We want to make sure that's last item. There we go. Now we can say last item set next item is equal to new item, and that is correct. All right, and then just like we did in the other add item, now that we've set the previous and the next of the new and the last item, we can go ahead and set new item as the new last. All right, so I can say last item equals new, just like that. All right, and of course, we're going to want to increment the count just like we did before. So what else would we want to do here? Let's see. Maybe we want to remove an item by name. So we can say public, and we'll make this a Boolean. We'll say remove item by name. And we'll have its lone parameter be a name, or be a string, I should say. All right, so we'll say item found equals find item by name. So here we can say if item found is not equal to null, then that means that we in fact did find something. So we can say item previous equals item found dot get previous item, and we can say item next equals item found dot get next item, because what we need to do is when we're finding or when we're removing by an item's name, we could be pulling it out of the middle, so we need to reconnect the two items that used to be touching this item. So that's what this is all about. So we can say previous, we can say set next item, and this is going to be next. And then we can say next set previous item is going to be previous. Simple enough. And then we'll also want to make sure that we decrement the list count. Minus. There we go. And we can also return true. All right. And if we get to this point, this is where we just go ahead and return false. All right. Simple enough. Now we have this find item by name method that we need to write. So let's go ahead and say public item find item by name, and we'll say string name. Let's make sure that we we name that method up there appropriately. That's going to be important. Then we can say item current item is the first. So we'll start looking at the top of the list. So whatever the first item is, where we're going to start. And then we'll say while current item is not equal to null. So we'll keep going until we reach whosever next item is null, which is only the last item can have a next item of null. So that's how we'll know when we're through the list. So we can say if current item dot get name, and this is a string comparison, so we want to do a dot equals, and we'll say name, just like that. And you can say return current item. Otherwise, we can say current item equals current item dot get next item. All right, and if we make it all the way through that while without finding anything in here, so maybe we search for a name that's just not in the list, this is where we'll do a return null. All right, and of course, be careful returning nulls, because if you don't trap for that appropriately, like we are here, what'll happen is you could end up with a null pointer exception. All right, so what's left from there is just to we don't really need any setters, but having some getters on our first item, last item, and list count could be useful. So I'm actually going to do this a simpler way than I did in the last class. Let's go ahead and say source and generate getters and setters. Yeah, that's right, because these all open. So yeah, select getters. There we go. And let's go ahead and create these. There we go. See, now we have our getters. And we have one more thing. Sometimes we'll want to show the entire list, and to do that, we're going to need to be able to return that list as a string. So let's say public string, and we'll overload the default toString, just like that. And we'll say we're going to use a string builder for this, and I'll call that the return value. All right, and we'll say new string builder, and we're going to start with a carriage return, just like that. That way, the first thing. Oh, you know what? I have a semicolon there. There we go. That way, the first thing you see when you do go ahead and you do a toString on our linked list class is that it'll go ahead and create some spacing between whatever outputs ahead of that. So we can say item equals first item. All right, and then we can kind of do a similar loop to what we did before. We'll say while item is not equal to null, and we can say return val dot append, and we're going to pass in the item's name, so item dot get name, just like that. Oh, and I should actually spell out return value. That'll help. All right. And of course, we want to go ahead and put a carriage return after that as well. So we'll say return value append, and we'll say \n, just like that. And once we're done appending the contents of the current item, let's go ahead and iterate that item to the current item's next item, just like that. There we go. And when that is all complete, we will go ahead and return value. But remember, this is a string builder, so just returning it's not going to work. We actually do have to call the default toString method, just like that. All right. That should do it for our linked list class. Okay, now if we jump back over to our empty main, let's start by creating a new empty linked list. So I'm going to say linked list, and I'll just say my linked list like that, and we'll say new linked list. Okay, now let's go ahead and create some items. So I can say item, and we'll use the same cities that were in our diagram before. So we can say eldom equals new item eldom, just like that. Oh, do we not have a constructor that allows yeah, let's take a look here. No, we don't. Okay, well, you know what we can do? Let's do that, and then we can trim this down. There we go, just like that. So now we have our new item, and the item of eldom works just fine. So now I can say item Christwind equals new item Christwind, just like that. And you know what? I'm going to do 1, 2, 3, 4 more of these. So let's save myself some typing and go 1, 2, 3, 4. And we're going to do the town of Marin. And we're going to do the town of Lang. And we're going to have a town named Heroth. And we're going to have a town named Balran. Oops. All variable names should be starting with a lowercase. Anyway, so now that we have our items here, let's go ahead and say my linked list dot add item, and I'm going to start with eldom. Yeah, you know what? Let's just do this again. So I can do that, and I can say Christwind, and then I can say Allran, and then we can say Marin, and then after Marin we can say Lang, and then after Lang we can say there we go. So now we've defined our items and we've added them all to our list. Why don't we take a look at this so far? You can say system out.print line, and we'll say my linked list, just like that. Now you'll notice I don't have to have dot string on the end here because it is just implied. So I should just be able to run this and have it show our list. And there we go. Oh, right. So it's actually showing in reverse order, and that's because we're always adding at the front. So we added eldom, and then next we added Christwind, and Christwind became the new front. Then we added Falrain, Falrain's a new front, Marin, Lang, and Heroth, and finally Heroth is at the front. So that's kind of how that worked. All right. How about we test out some of the other methods here? So maybe I could say system out print line, let's say, does this list contain, and then let's say Christwind dot get name. And then I'll go ahead and put a question mark on the end there as well. So let's go ahead and put some logic in there around that as well. So we can say if linked my linked list Find item by name, and we'll say chriswind.getName, and we'll say is not equal to null. And in this case, we'll just say yes. And otherwise, if it goes through and returns a null, here we'll just say, oh, I should make sure that that is an actual system out method there. All right. And in this case, we'll say something just like, no, sorry, not found. Just like that. Okay, so we know chriswind is in here, so really this should say yes. And it does contain. All right. Well, what if we mess around with this a little bit and say to lowercase? In this case, if I run it and it says no, sorry, not found. And of course we know that's because Java is indeed case sensitive. So if I'm forcing what I'm searching by to be lowercase, well then it's not going to match in that capital C there. So let's say removing, and we'll say we're going to remove Marin. How about that? So now let's say my linked list dot remove item by name, and we're going to say Marin dot get name, just like that. And of course, once we do that, we should actually print the list back out to make sure that that works, just like that. All right, let's try this. Okay, so we have our original list. Marin is in the list. And then we see, hey, removing Marin, and Marin is no longer in the list. So that worked. All right, so that concludes this little exercise. That's, how to build a linked list in Java. The main thing to remember is that, again, the order is maintained by the items themselves. So the linked list is really only aware of how many items are in the list, the first item and the last item, and that's it. And in between, each item knows which item is before it and which item comes next. All right, that's it. I hope you enjoy this. And of course, check out my book, Code with Java 21. All right, have a great day.